All right. And speaking about Prague, actually, we are pretty close to end. We are pretty close to the final talk, which will be actually about what's happening in Prague in Microsoft branch in F# compiler team in the group of, I would call them magician, because whenever they start talking really deep, I totally stop understanding what they are doing. But I think it's good to welcome here.
Only sad we don't get to see Kevin Ransom, who's hiding in Redmond and didn't want to join us. But Kevin, if you're listening, hello, we love you, and don't slit your throats or anything. Over to the F# team in Prague now.
Hi, and thanks so much. Thanks, Roman. So yes, greetings here from Prague. We are streaming from the Microsoft building here. It's two Peters, Adam, Tomasz, and we are missing Vlad and Kevin, who could not be with us in person. And we are going to give the very last talk, each of us individually, so we will see the four of us reaching at the same screen. Thanks for those who stayed till the end, either if you watch online or on a recording, and I hope you will enjoy it. All right. So let's go to it. I am Tomasz Gorszu. On GitHub, I am C-Grow, and I'm going to present some of the recent advancements from the .NET/F# repository, which is where most of our daily work happens. So let me start presenting. Yeah, okay. Now you get some recursion. And now you see the screen. So most of the work which we, the F# tools team do, is in the GitHub repository .NET/F#, which is where the source code for the F# compiler, the library, and the Visual Studio editor support lives. So this is where we do daily contributions, but not just us. It's also the amazing community contributors who really bash the repository every day in huge amounts. So if you have a few minutes after the conference is over, just go there to this repository, click on this little Insights button, and you can appreciate the active development which is happening here every single day. So you can just see from the numbers how quickly the repo is growing, and every single contribution counts. So be it bug fixes, tooling improvements, new documentation, or the improvement of diagnostic messages, everything is building up towards a better experience you get when working with F#. So now to what I wanted to present is a little showcase of a few selected changes which have been contributed during this year, so 2023. They are coming up with F#8. Right now, they are available in the preview versions of F# and the .NET SDK and Visual Studio. You can watch all the active developments in the F# repository itself. And if you want to use them experimentally, you have to use the language version set to preview. F# uses feature toggles to control which features go to which version of the language. And just to give you a little look, what is currently in the preview stack and what will hopefully, or like to a large extent, be moved to F#8, you can go to this language feature setting and see how many individual features are already prepared in the stack and waiting for the move from the F# preview to F#8. So there is a large dedicated section of mapping between features and language versions, and you can see from this how many features have been added over the past F# versions. So let's go back to show some of them. I will also show some which I personally like a lot, and they have been contributed by our community contributor Kerams. So the first of them is the nested record field copy and update. So when you have an F# record, normally if you want to update a single field of it, it works fine. You use the diff statement and you can update an individual field. But with this contribution, you can also update nested fields with the dot notation and save you a lot of typing. So you can update a record and go with property access separated by dots and update a low-level field which is nested deeply inside. And you can do this on multiple levels with same go. So you just separate the updates with a semicolon, and you get 2 updates in one shot on different levels of the same record. Another small thing which might be appreciated by people doing data science is parse support for arrays with many dimensions. Before that, F# only supported up to 4 dimensions in multidimensional arrays. With this change, we can go up to 32 dimensions, and the parse supports with it. So if I declare a type with many individual dimensions, I hover over it, I can see this is an array of 10 dimensions. A small thing which I personally like, and this was a limitation in F# before, you were not allowed to do a try with in sequence expressions. This is what is used for building sequences, but also non-trivial lists or array builders. So with this change, you can also start using the if clause and therefore catch exceptions which happen. But that's not all to it. You can also yield from the exception handlers. So whenever an exception happens, you can also yield from it as you could from the normal expressions which you use in your builders. This can also work recursively. So for example, if you want to go a little nuts, you can yield the same function in which you are in an exception handler. So you can create an infinite sequence which is always throwing an exception, catching it, and then yielding itself. And it works. Two more extensions which are again contributed by our community member Karams is expansion of the expressions you can use to define literals. So those are compile time values, but the compiler can evaluate them. So instead of just typing a single value, you can now also use basic arithmetics like division or multiplication or even bit shifts. And you can use this for values defined as literals, but also for values which you put into attributes. So even in an attribute value, you can use some simple arithmetic expression. And the same thing works for enum definitions. So if you are building some enumeration with defined as flex, and maybe you don't want to remember or hard code the powers of 2, you can use a bit shift expression to do the sequence of powers of 2 for you. Yes, you can use 1, then 1 shifted by 1 bit, 1 shifted by 2 bits, and it all works at compile time, and the compiled binary then has the values which are calculated for you. A contribution to the F# core library, which I like, is the extension of the array.parallel module, which used to have only a few operations, a few basic ones, but was very thin compared to what you can get in list, array, or seek modules. So with this expansion, you get a lot more standardized functions, which are especially meant for CPU intensive work, either for very large arrays or expensive functions passed in as a parameter. So with this new change, you can also get sorting, grouping, aggregations, or some finding functions in parallel. So if I just have a look here, I can have, for example, array.parallel exists, and instead of searching through the array using a single core, it utilizes all the available logical processors which the computer has. And at least one small Visual Studio improvement, something which used to exist for C# for very long in Visual Studio, but was missing for F#, is the task list functionality. So now you can write some standardized comments with predefined strings. What is pre-configured is to do or hack, and you get a nice task list in Visual Studio, which builds you a list of things you should not forget in your code base. Okay, so I now pass it over.
Okay. Yeah, here. So, I'm Peter, or Peter in Czech. I code, comment, commit, and tweet as PS Penake. I'm the man behind the sheep avatar there. I have been a software developer for a while, about 3 years in Microsoft. I was mostly doing C#. F# was always a hobby. And a year ago, this F# position opened, and I decided to join. And that decision, I rank it among like the top 3 best decisions of my life. So since I've joined, I have focused a lot on the editor experience. I added the initial version of the type hints. I'm fixing the code fixes now. I'm doing some integration testing. I'm generally kind of obsessed with testing a bit. I try to consolidate what we have and add some more. That's a long journey. So yeah, I'll not show anything. I'm just talking about myself here. So for me, working in F# means working with the community. I'm so happy to see a lot of people bringing so much value to the language. I'm really proud that our community is friendly and people are helpful and patient and respectful. That means a lot. Every day I go to work, I open the pull request page in the repo. It just makes me delightful to see how much is going on there. I hope one day we bring the number of open PRs to 0. That's my ultimate developer dream. Yeah. I learned a lot from my colleagues and external contributors and look forward to the bright future of F#. That's it for me. Adam.
All right. Hello, everyone. My name is Adam Boniecki, Abonye on GitHub, and I have joined the fsharp compiler team in September. I would say I'm maybe a member with the least experience with the compiler, but still I am very excited to talk to you all about this one thing I have worked on quite recently. I want to basically, in this couple minutes, achieve 2 things. Let you know about the new language feature that is available in .NET 8 if you use the language version preview. And also use this as an example to show you how, basically, what's the process for adding a new feature. So let me figure out how to share. Okay, I am sharing now. I just need to switch a window as well. That's on me. All right. Yeah, so the feature is extended syntax for string interpolation. And I'm going to assume that you are familiar with string interpolation. If not, it's great, so check it out. But basically, the version that you know and love is you put $1 before the string literal, and then the curly braces that you put a expression that will be sort of evaluated and spliced into the string. And then the new addition is that you can put multiple dollars, and then you don't have to escape the curly braces, whereas usually you would have to double them. Now you don't have to, and then you just have to put as many curly braces as the dollars at the beginning to start the interpolation. So that is the feature. It's already there in the preview version of the language. and what's the process? How does it work if you want to maybe start contributing, or maybe you already have a couple of bugs that you have vanquished and you want to add a language feature now. Where? So you would go to a different repo actually than our compiler. It's the fslang suggestions, and there you can create a new issue, which will be the language suggestion, or you can browse through the existing ones where the community and in particular Don discusses the issues. And if you see one that has the label approved in principle, that means basically it got a green light. It doesn't mean your implementation will be immediately merged, but this means you can start see if someone is working on it. If not, you can figure out what's needed there, and you can start working on this. So this is the language suggestion that has inspired me. The use case of embedding different languages in fsharp, I think, is great. So that has drawn me to this one. Fable is much beloved, and here the Fable-lit library could be less clunky, let's say, if they had this feature. So I saw the suggestion with the approved in principle. I saw it's not actively being worked on. And the next step was to write an RFC. So, sorry. All right, let me just, yeah, so the next step is the RFC, which stands for request for comments. It's like a kind of a more formal specification of what the feature is. There is a template. It's in yet another repo, fslang design. There's a template for this, so you will know what needs to go there. So I have written this RFC as the next step in parallel with creating a proof of concept, because without that I wouldn't know if I can actually handle this, and also I wouldn't know what to exactly put in the RFC. And a member of community, Abel, has helped me a lot with the RFC. So if you're listening, thank you, Abel. And if you want to actually know more about the feature, this is a good place to see a very detailed overview of how it works. Now, if you want to try it out, you can do so in, I would recommend Visual Studio. But before I go there, since I'm actually not a front-end dev, I have a healthy respect and fear of CSS. And I will not do a full-on demo with Fable-lit. Also, Fable, unfortunately, it has a fork of fsharp compilers, so they need to make some updates, I think, for this to be available there. So I just want to copy this from the well-known W3 schools example of CSS and move to Visual Studio. So yeah, let's imagine you are working on some CSS. And as the Fable-lit library lets you have some literals, you want to why the space didn't work? Yeah, you want to have this as a string literal, but you have a bunch of curly braces there that will make it annoying for you. So, I mean, of course, in this case, I'm pasting the finished CSS, so I could just find and replace and hope that there is no issues, that it just worked the way I want it to work, right? But yeah, to make this actual interpolated string, let's put an expression here. Let's make this. Let's make this like this. And so for the interpolation to work, I have to put two $signs in front, and then magically you don't have to escape any of the braces. They can be as is, so you can paste whatever CSS you want, or you can write by hand and not worry about this and just use double curly braces for escaping. And if you want to put % somewhere, you also don't have to double them as you would with a regular string interpolation. And that's pretty much it. That's all I wanted to show you. So with that, I will hand it over to Petr.
Hello, I'm Petr. I'm the second Petr on the Prague fsharp team. On GitHub, I go by 0101 for some reason that I don't remember. And today I want to tell you something about a thing I've been working on for a while now. It's called a transparent compiler, and this is a working title, so probably it's not going to be called that eventually. Maybe it will be snapshot compiler or something else that someone will suggest. And it's kind of a thing for our IDE experience for the background incremental compilation. And so what do we want from that actually? We would like to have the immutable compilation model where the IDE gives us the full input with everything, and the compiler service just returns the result. And also, we would like to make use there of the great community contribution of dependency graph checking, which I think we heard about today earlier, which basically enables us to do parallel type checking where it's possible, and also skip checking files that are necessary for the given result, such as some type checking of a file. So what do we have now? We have incremental builder, which is stateful, and it takes paths on the file system as input instead of the actual source code, and it kind of depends on the file system timestamps or notifications. And it's inherently sequential, and it kind of means a rewrite if you want to make it support the graph checking. And so how does it work now? Incremental builder basically creates and maintains a chain of dependent async computations. And then if it's asked for a type checking result, it goes to that node in the chain, and that one triggers the previous one, and so on, to get evaluated and to avoid basically double computations and stuff like that. But it can be a bit opaque, which is the reason I chose my working title as transparent, because you can get code like this, where you get a previous result by running get or compute value on previous computation, but from there, there's no way to go to definition of previous computation and actually see what it's doing, because it has been created by some other function somewhere else in the past. So that can be a bit annoying when you want to debug it or change it. So how is transparent compiler, how will it work, and or what does it do differently? So this one has no state, and basically every request is computed from scratch for the given input. However, for it to be efficient, we just cache the computations and their sub-computations, so we can maintain some performance. And this is backed by an asynchronous cache, so it can handle a lot of parallel requests we can get from the IDE, and also cancellation. As for example, user is typing, we're getting hammered by a lot of requests. And this async cache basically detaches the computation to a task or async thing. And yeah, if someone asks for the same thing to be computed, they get a link to the maybe already computed result or to the running tasks, and they can await it. And the code is actually pretty straightforward, because everywhere it just does whatever it would, except there is some caching wrapper. Unfortunately, stack traces aren't so straightforward, because we have to detach from the original caller in order to be able to handle cancellations. But yeah, I don't know if we'll find a way to fix that, but it is what it is for now. And some example, let's say if there was a project with actual dependencies of source files that look like this. In incremental builder, it will pretty much make this kind of chain, which you cannot do much about. And here is some kind of trace for what it looks like. So if we want the result for EFS, we just have to go and compute everything in sequence. And here's a trace from the transparent compiler current version, where you can see that the 3 files basically are type checked in parallel because they don't have any dependencies between them. So what is the status of this work? It's still very much work in progress. It kind of works, so you can actually try it out if you're brave, and if you build it from my branch, which I will link to. And it will probably work fine with fsharp only projects. Without signature files, those are a bit tricky. But there's a lot of work left to do, a lot of optimizations and other stuff. But the initial benchmarks look pretty promising, given that I did the benchmarks correctly. Here's some example. This is on a Giraffe web framework project. And yeah, so here, these two are using transparent compiler. And also this is with signature files or without. We can see some significant time savings and also less memory consumed there. And you can check it out on GitHub in this pull request, and of course give any feedback. So that is it from me. I guess we are pretty much on time, but maybe we could handle some questions or hold on.
So I suggest that for the questions we can do some magic here.
Abracadabra.
Would you and transport everyone from the Prague fsharp team to the same mic through time and space. No, just space, I think.
Yeah.
Not very far. Okay, let's see what questions have we got here.
Yeah, there are some comments that all the stuff that you show will pair nicely with the language injection tooling for strings. So yeah, here's the question actually.
Wow. How do you do async cache invalidation in transparent compiler?
Oh, so actually there is...
Here's Mike. So
oh, hopefully you can hear me. Actually, there isn't cache invalidation as such. It's kind of most recently used cache, and the whole trick there is to compute the proper key. And then if there's a request with a new input, say like some source code that changed or some dependency changed, then basically it won't be found in the cache, and the old version will just be kicked off the most recently used eventually. So there is no actual code for invalidating cache there, and hopefully won't be needed.
I'm trying to see cancelable tasks.
Yeah, those should be involved at some point, actually. Vlad is doing some work on that in our VS tooling to handle everything through cancelable tasks.
This one is interesting. Will you recommend adding signature files for all the fsharp projects that suffer from slow compilation?
I mean, we can recommend it. If that's your last hope, then do it. It will most likely be faster.
I mean, I can maybe recommend to separate the parts of the big project which are not changing that much, which are fairly stable, and then create signature files for that. But personally, for anything which is like very live and changing, it's a nightmare because you have to maintain stuff on two places. So if you have a clear API separation, that you have a signature which remains stable and only the implementation changes, then signature files are a good fit and will improve the tooling performance as well as cold start compilation.
All right. Any other question?
I don't see any. I think people are just happy. So that's what we wanted.
Yes, exactly. So I think that's a wrap, right?
Sounds like that.
After how many? 7 hours?
7 hours.
Jesus,
sharp.
It's 10 p.m. here in Prague. We drank everything that was here in Microsoft. I mean, of course, non-alcoholic beverages, but all the coffee, all the Coke, everything is drunk here.
Well, it's just because they didn't have alcoholic beverages.
Yeah, of course, yeah. So I think once again, we should really thanks to our colleagues here in Prague, to the Microsoft team, but also to our colleagues, I would say worldwide, who are helping us doing this amazing online conference. And we should probably look forward for the next one, right?
I'm sure there's more people we have to thank.
Yeah. Okay. Do it, please.
All the speakers.
Of course, yes. Speakers.
All the attendees.
Of course.
All the people who will be watching the videos in the future.
Yes.
Because there will be videos. everyone who's donated to the drones. We'll keep that up. So we still need a couple more dollars so that we can buy a drone. Send us suggestions of what you want to print on the drone. I think that the term F# spelled properly allows for very many interesting options there. So do that offline later on, and that's everyone's thanked.
Yes, I think so.
Well,
and contributors, of course, contributors to all F# open source code. Yes.
So make sure to hassle us again in sort of year and a half, because it takes a bit of effort to put these things together, but we love doing it.
Yeah.
And it will definitely happen again.
So thanks a lot, and good night, good day. See you in 2 years.
See you soon.
Bye.